Well, hello and welcome to another training tutorial. Today we'll be discussing VPN troubleshooting. Now what I'll do first is describe what the scenario is going to be, and then we'll discuss how I set up ping and traceroute utilities to gather statistics, and then we'll review the log files that these statistics have gathered. Alright, so today the scenario is as follows. We have a company called Acme Furniture who uses an ERP solution. An ERP solution is a type of program that you use to basically run your entire business with, to do your orders, to do your invoicing, to manufacture products if you're a manufacturer, and so forth. Okay. Now, Acme Furniture has their headquarters in New York, and they have two plants, one in San Jose and one in Miami. Okay. Now, so people in San Jose are often complaining that they find the software runs very slowly. Okay, and sometimes it is extremely slow. The connectivity between Acme's Furniture three offices is done via VPN, and the reason they chose VPN is obviously because it's the most cost-effective method of linking the offices together. So this is the network diagram that we have for Acme Furniture. As you can see here, the server itself that everybody's accessing is in New York. Okay, and then we have PCs here in San Jose and PCs here in Miami. Okay, what happens is they have SonicWall. They're using SonicWall to do their VPN tunnels between the two plants to the central head office. So I find a picture, especially when you're trying to explain your network to other people, there's nothing like a picture for people to get a quick glance at your network and understand how it works. Okay, so for those of you who don't have Visio, or I strongly recommend that you purchase it and then start documenting your network. So when you're talking to vendors or third-party product companies that are going to help you to manage or troubleshoot your network, by having a diagram, it gives them a head start as to understand what's going on and how things are laid out. Now, like anything else, when you're asked to investigate an issue, you're doing some troubleshooting. So you're putting on your detective hat, and you got to figure out, is this a problem that's spread across the entire organization? Maybe just to a user, maybe it's just to a location. So basically, you got to start asking questions, right? So if you're a consultant who's just been brought in, or you're the IT guy who works for Acme Furniture, and you're asked to solve the problem, you got to start asking the questions like, I'm giving here two examples, right? Are users in Miami also experiencing this slowdown or this slowness that people in San Jose are reporting? In this particular case, they said no. So right there, that tells you that it's not a company-wide problem. Okay. Secondly, what you can do here is you can do a ping test, right, from the PC. Let's say that's over here, the 10.0.0.55. So from this PC, what you can do is you can ping the IP address of the router in New York, right, which is up here. Now, if the ping results that you're getting are the same as when you're pinging the server, then at least it tells you the problem is not with the server, right? Because if the ping results of the server, when you're pinging the server, this IP address from this PC here, if the ping results were much slower than when you're pinging the router in New York, it kind of tells you that there's something wrong between the router and the server itself, which is usually most likely a problem with the server. So if you ever get these kind of results where you're from your location, your faraway location, you're pinging the router or the firewall and the response time is good, but yet when you ping the server, which is probably the next hop inside your network here, that it's slow, then chances are it's a local issue within the New York office, and most likely it's probably the server you're trying to access that's overloaded or something's going on there. Okay, so in this particular case, they're we're saying here that the pinging the router or pinging the server, it's the same response time. So right there it tells you that it's kind of probably not the server itself. Okay. Now, obviously, you can pause if you like these little batch files that I've written here. You can maybe just pause the video and start copying them down. But this is a traceroute batch file that I've created, and all it does is basically it does a date and timestamp of when I run my traceroute and when I do my ping. Here the ping I'm doing, by default in Windows, when you do a ping, you get 4 tries. So here I say, no, give me 10 tries. And then I echo all this information and the results into a log file, okay, which is in this case called ping trace.log. Also, what I do is at the end of the day, I don't want my log file just to grow forever. So what I do is at the end of the day, I want to rename my log file so that I have a log file for every single day. Okay, and basically this batch file here, that's all it does. And as you can see by the example here at the bottom, what happens is it appends the date to the name of the file, so that I can see here by date. So it's day, month, year. Okay, so here, for instance, this one here is from November 25th, 2013. Okay, so this batch file here, the rename batch file, that's all it does, you know, and it's very simple, but and it does the trick. Now, the next part here that I want to talk to you about is you have 2 batch files, one that does the ping and the trace routes, and then another one that does the renaming. So what I want to do is to really get, I don't want to overload my network. You know, I know it's not a heavy traffic, but I don't want to, you know, continuously do pings and trace routes, because otherwise it's going to be too much information. But I figured every 4 minutes is kind of a good number that I can use to, you know, get a good sense on pretty often, like basically 12, how many times? 15 times an hour, I can have a snapshot of what's going on in terms of the performance of the VPN tunnel. Okay, so what I would do is I would install these 2 batch files on a PC in San Jose that would basically constantly test the connection of my VPN connection to New York. Okay, now also what I do here is I want to make sure that when I run the batch file to rename the log file, I want to make sure that it does not coincide that when I'm doing the actual writing to the log file with my statistics, because if the file is in use, I cannot rename it. So I got to make sure that the time that I rename it at is like an odd number and not an even number, especially if I start, let's say, at 10 o'clock every 4 minutes. It's going to start always on an even timestamp. Okay. And then basically you let this run for a few days, or you can let it run forever. It's really up to you. And then you look at the log file to see what you're getting. Okay. Now here's a sample of a couple of entries inside the same log file. Okay. If you look at the time here, this one here, I took a snapshot of the log file here at 1:30 and at 9:30 at night. Okay. And the 2 commands that you start in the batch file is basically this. This is a trace route, and it does 10 pings and gives you the results. So this, by doing 10 pings, it'll give you a better sense of the average when you just look at it visually to see the numbers kind of match. It doesn't go up and down like a yo-yo. And here you see basically all the different hops that it takes to get from San Jose to New York. So we're talking about 21 hops here. So there's quite a few. It has to go through quite a few routers before you can get to New York. And I just wanted to show you a glimpse here of it doesn't seem to be matter which time of day you're doing these trace routes, because at 9:30 at night and 1:30 in the afternoon, we're looking at pretty much very similar results here. Okay. So based on the numbers that you saw here, right, we're talking about ping results of 114, 112 milliseconds. So how does that compare to a place if I just go to this, you know, I've talked about this website in my other video called TCP/IP Tables and Tools, where this is used to be called justping.com, and what this does is it pings from 50 different locations across the world an IP address. So what I would do if I were you, I would go to this website here and I would enter the IP address of my New York router, okay, or my New York firewall. The public IP address of the firewall or the router in New York, and I would enter it on this website to see what kind of ping results I'm getting. Okay, and then obviously you compare this, you try to find a city out of those 50 that's close to where you are. So in the case of San Jose, I'm going to be very interested in ping results from cities in California, because I would expect that my results should be fairly similar to this. Okay, so from experience I can tell you that when you're pinging from California to New York, the average ping results should be anywhere between 50 and 70 milliseconds from what I've seen in the past. Okay, So the fact here in this particular example that we're getting on average 113, it's almost twice, it's basically twice as slow as it should, as you should expect to see. So right there, that kind of tells you the result that I'm getting from my office in San Jose is not normal. There's something wrong. Okay, and also by having a log file that captures information every 4 minutes, if people tell you between there's a certain time period during the day where my performance is really a lot slower than the normal slowness, then you can see if the entries in the log file around that time also match with what they're saying, because then you'll know that everything is related to what the log file that the results you're seeing in the log file for your trace route to New York are truly representative of what people are experiencing. Okay, and then you look at the log file to see if there's anything kind of weird that needs investigate, that you should get investigated by your ISP. Okay. Now, like I said before, I have another video called TCP/IP tables and tools. In there, one of the big things I do is I try to explain use a couple of analogies to explain networking concepts. I use the postal service as an analogy, and I also use the road system as an analogy. So that having been said, if we like I said 1,000 times, a picture is worth 1,000 words. So if I take my trace route that you see over here from the log file, and I want to use my analogy to try to understand what I'm seeing here. So like I said in my previous video, this is basically your servers here in the New York office, let's say, that you're trying to access. And sorry, my mistake. No, these are basically some of the machines you have in San Jose, and basically you want to go out on the internet to get to New York, okay, which is out here. So hop number 2 here could potentially represent the router that the ISP installed at your location. Okay, then this is obviously the internet link that the ISP provided for you in San Jose, and hop number 3 here is probably the router at the ISP's head office, okay, or central office. So like I said in my other video, each hop here is a router. So a router is basically a street intersection, if you want to start comparing with a road analogy. And the brains of a routing device, for lack of a better term, is equivalent to a traffic cop that just directs traffic. Okay, so when you get to hop number 9 here, right, the routing device over here, which is this intersection here, the router itself says, okay, you're trying to get to New York. So the only way I know how to get to New York is by going in this. Oops, my bad. Let's go back here for a second. The only way that I know how to get to New York is by sending you in this direction here. But as you can see here, there's a traffic jam. So it's not like this guy should know better, but it's the only way he knows how to send you to New York. So that's why here, if you look at this example here, what happens when you try to get to hop number 10, there's a serious slowdown. Okay, and you could say, if you want to use again a road analogy, it's because there's a traffic jam, heading towards hop number 10, which is in Dallas. Okay, so in this particular example, right, if somebody tells you, if you don't have any tools, you don't have a trace route, log file to refer to, you don't have a tool like PRTG, Traffic Grapher, to determine if your local internet bandwidth here, if it's sufficient or it's fully saturated with traffic. So if you don't have any of these kind of tools, and all you know is, I'm in San Jose here, and all my PCs in San Jose, when I try to access the application that's in New York, it crawls. Okay, so if you don't have anything like that, right, any tools to tell you really what's going on or give you a glimpse of what is going on, you're most likely going to say, oh, it's probably my internet connection here, it's probably too slow. So then you're going to say, or you talk to your ISP, and your ISP says, yeah, you need to increase your bandwidth here because it's too slow. So you're being conned into a false sense of this is going to fix your problem, when in reality the problem is not even there. The problem is further upstream, right? The problem is on hop number 9 here. So that's the problem when you have no tools, you have lack of knowledge, and you're relying on maybe on an ISP to to be proactive and to really to try to help you and tell you what's going on. You know, they're there. Their job is just to make sure that you're getting the throughput that you're paying for here. What happens beyond this point here, they really don't care. And technically, they're not committing to. They don't have an SLA to guarantee performance. They just say we're going to give you good performance here, and beyond here, you're on your own, kind of thing. Okay. And in this particular case here, for this customer, you know, for the person who's in San Jose, right? What happens is this is tiny.net here is the ISP for San Jose, because obviously after this is the internal router in San Jose, and then after that the ISP kicks in. But what happens is the ISP does not bring traffic to New York all by itself. It has to pass it on to a partner, and in this case we're talking about Surf2. And Surf2, as you can see, brings it most of the way, and then just before it gets to the customer, to your location in New York, it passes it to the ISP of the New York office, which is cbc.net. Okay, so Surf2 here is what we call an in-between, or a tier 1 partner, and they're the ones that just make sure they get the network traffic from San Jose all the way to New York. So, and obviously the problem that we're encountering here at hop number 10 in Dallas is this router belongs to Surf2.net. Now, are you a customer of Surf2.net? The answer is no, because in San Jose you're a customer of TinyNet, and in New York you're a customer of CBC.net. So you have no leverage with Surf2 to say, you know, you need to fix this for me. You can try to call them, you know, if they're cooperative or they want to help you, that's fine, but they have no obligation to do so. And so the only thing you can only do is talk to your ISP on either side and say, can you guys try to put pressure on Surf2 to resolve this issue by sending them these kind of logs, right? But again, you're helping yourself, because you have proof that there is a problem, and by providing these kind of logs, they can act on those kind of things, right, if they want to. So ultimately, Surf2 may say, no, we're not changing anything, and we're happy with the way we're set up, and just because you have a problem doesn't mean that no, everybody else has a problem, or if we fix your problem, we're going to create other problems for other people, so we're going to leave things as they are. So ultimately, you know, you're not sure if the solution is going to be resolved in this situation, right? So overall, okay, we've kind of confirmed here that the problem that people are having in San Jose is VPN related. It's not related to the internet link. It's related to the hops along the way on the VPN. Okay, I mean, obviously we did not show it here, but to a point you could see that it kind of shows by looking at the logs that if you would have had an internet problem saturation on your internet link here, these numbers, and for instance hop number 3, sorry, these numbers here might have been in the 50s or 60s or even higher, right, which would not make sense, because you don't expect numbers to be high so quickly. So if you would have these much bigger numbers here at hop number 3, right away you could say, oh, maybe I have a problem with my internet link. But because the numbers are so low here, it does not kind of point in that direction. And again, if you have a PRTG traffic grapher installed on a computer at the office, you're also monitoring that internet link, and you're seeing that there's no problem. Okay, so obviously, like I said earlier, TinyNet and Surf2, if they cannot redirect traffic, you know, instead of going through Dallas, go through another location, then you know, the ISP in San Jose will need to be changed, because unless you're willing to live with the problem, if you want to fix it, then there's nothing else you can do at this point with this current ISP and Surf2.net, unless they have other options that they want to offer you. So if you're going to go to another ISP, and let's say this other ISP has their own issues or other issues or similar issues, then you're kind of stuck, right? Your San Jose plant is having difficulties accessing your application. So you may have to look at other options to establish that connection. And other options usually means they're a lot more expensive, because you may have to install a dedicated link between the two offices. So that means a higher premium, but at least you're going to get guaranteed performance, because you're not going through the internet per se. And whoever you're going to get that dedicated link, you're going to be paying an arm and a leg for it, because it's going to be expensive, because it's all for you. And ultimately, we were able to identify the problem by using tools that are costing you absolutely nothing. These tools are free. Therefore, it's much easier for you to be able to say, I want to set this up. It's not going to cost anything. So your boss has a very little chance of saying no to using free tools versus, tell them, I want to buy this software package, but it's going to cost us $10,000. Then obviously he's probably going to say, no, we don't have the budget for this, right? So ultimately, my purpose here was to educate everyone here on how to troubleshoot these kind of issues, and by using tools that are free, either my batch files or it's a combination of my batch files and the PRTG traffic grapher. One thing that I wanted to talk to you guys about was scheduling the batch files. Okay, so if you recall, I said I want to do this every 4 minutes. Okay, now one of the things when you schedule a batch file to run on a regular basis is it gets annoying after a while if you're using that computer where these batch files are running, because every time the batch file is going to run, you're going to get a little pop-up window like this while you're working. So you want to try to run these batch files minimized so they don't get in your way. Okay, so what I'm going to do here is I'm going to show you what I've done. Okay, so as you can see here, we have PRT, the ping batch file that runs every 4 minutes. Every day for duration of almost the entire day. And then the time is wrong here, but I would rename here the batch file, let's see, at 23:59 for instance. I would rename the batch file so that it doesn't conflict or doesn't get the file is not in use, and I can keep a log every day. Okay, now when you schedule these batch files and you don't want them to run in the foreground, what you do here is this is a Windows 7 system, right? So I'm in this is what they call the task scheduler here, and what I do here is basically this is what I'm using. The program that I'm going to execute is called CMD, which is command.com / then as argument I put /c as a parameter. Basically I'm running this as a copy, like in a sandbox. And then I initiate the start command in Windows. It's start in Windows 7. We're launching the start space /min for minimize space, and then the batch file I'm trying to run. Okay, there you go. And I'm obviously starting this in my ctemp directory because that's where my log files are being written and so forth. Okay, now I'm putting temp here, but obviously you can change these things to another. You can make it a log directory, but if you're going to do these kind of changes, then obviously in the batch file itself that I showed earlier, you got to make all the appropriate changes, right? For instance, this guy over here, right? If you don't want to write in ctemp and you want to write in clog because you don't want to, you clean up your temp directory on a regular basis. So this obviously these would have to change and point them to a different place. Okay, and obviously the text here you can say, ping from San Jose to to HQ. So this way by looking at the log file every single time when you look at the entries, that when I'm reading this, when I look at the log file, I don't have to go back to the file name to figure out where am I pinging, because you might want to set this up. Let's say in this particular example, you might want to set up this batch file logging in the San Jose office and also in the Miami office in case there's a problem, and maybe mail or send you these files, these log files, to the New York office because that's where you're located, and you can review them whenever you want. So by having the proper text inside the log files, you don't have to go back and forth and figure out which log file am I looking at. Okay, so I hope this little tutorial proved to be useful for you, and these things that I've discussed here will help you troubleshoot, and at least it's a beginning. You know where you're starting from. All right, so good luck, and I'll talk to you later. Thank you.